What's up guys, my name is Nathan and I am with my teammates to discuss how to measure total current and voltage in different types of circuits. On the first part, the topic is all about circuits with resistors, so the total resistance will be measured and also the total voltage and current. And in the second part, the circuits consist of capacitors and so my teammate will explain how to get the total capacitance, voltage and current. So listen very carefully for you to understand what they will explain. Good luck and enjoy learning.
So today I'm going to show you how to measure total resistance, total voltage, and total current of a circuit that contains resistors using Multisim. So for the total resistance, we have to do is to connect a multi-tester in each end of the circuit and double click and click the resistance, then run. It shows 6 kilo ohms. Next part, I'm gonna show you how to get the total volts. This time we need a power source of DC power source of 12 volts. Given, connect this multi-tester to the positive side and this end to the negative side. And then in volts, the tester, run it, shows 12 volts. Next part is the total current. We need an ammeter. Connect the positive end of the ammeter to the positive side of the circuit and negative to the negative side. And then run. And there it shows 2 milliampere. Don't forget to contain a ground in the circuit because it makes sure that the nodes are connected to each other. Okay guys, so this time we will measure the total resistance, total voltage, and total current of this parallel circuit. So first, for the total resistance, remove the power source first. Then connect each terminal to the circuit. Then run the circuit. It shows 1.25 kilo ohms. Then for the total voltage, now we need a DC power source, and connect each terminal to the circuit, positive side, negative side, then run the circuit. It shows 12 volts. And for the total current, again an ammeter, positive side to the negative side of the circuit, run, and now it shows 9.6 milliamperes. So after the measuring series and parallel connectivity, now let's move to the combination of series and parallel, which is series parallel circuit. So same procedure. Measuring the total resistance, connect the positive terminal and the negative terminal of the circuit, then run, and it shows 3.964 kilo ohm for the total resistance. And for the total voltage, again we need the power source. connect the positive side of the source and the negative side of the source. Then, and for the multimeter, connect positive terminal to the positive side of the source, the negative to the negative. Run the circuit. There it shows 12 volts. And for the total current, uh, again, ammeter, positive side, which flows here, and the negative side here. Then run the circuit, and there it shows 3.028 milliamps. So thank you for listening. I hope you learned. Peace out.
So for this circuit, we'll use DC power. So we'll put our DC component, DC supply, and then we'll search for resistor and put it in the circuit. And then we'll search for capacitor. Then we'll place 3 multimeters so we can measure their voltage and current. Then our last component is the ground. So in Multisim we need to put the ground so that the circuit will be complete. Then we connect the wires from the source to the resistor. Then to measure for the current, connect the resistor in series with the ammeter. Same with the second ammeter. Then connect back to the source. Then we'll adjust the wires a little so that it will look better. And then connect the ground. Then connect the voltmeter in parallel to the capacitor. And then we'll click it. Set the voltmeter for volts and set the ammeters for current. And then run the circuit. So if the capacitance of the capacitor is too small, it will just act as nothing there. So you need to make the capacitance bigger so that it will store electricity. So there's a flow of electricity from the capacitor inside and outside. So in this circuit, we'll use DC power again. Then we'll put the ground there. Then we'll now search for the capacitor. Then resistor. Then we'll change the property of the capacitor, increase its capacitance to 10 farads. And we'll copy it because we'll be needing two of them for a parallel capacitor. Then we'll connect the resistor to the voltage source, and then we'll again put multimeters as ammeters and voltmeters in the circuit. So we'll put the first ammeter, we'll connect it in series before the capacitors. Then we'll parallel the two capacitors each other. Then the second ammeter, which will measure the output current by capacitors. Then we'll connect the voltmeter in parallel to the capacitor. Then we'll connect and close the circuit. And set the ammeters for current. Then run the circuit. So I already built the circuit, and we'll just need to connect the wires properly. Again, we need to connect the ammeter in series in the circuit, and we'll put it there. Set aside there the two ammeters, and there you will see the current flowing inside and outside capacitors. Then we'll measure each of their voltages. Connect the voltmeter in parallel with each of the capacitor. Then we'll connect it to the second capacitor. And run the circuit. Then we'll connect it with the third capacitor. And then run the circuit again. So we got the same value because the two capacitors are connected in parallel.
And that's all for now, guys. I hope you learned something from us, and thank you all for watching.
When I close my eyes, I can